databases in your cloud system. So if you want to access the database, so you should have the query languages, right? So it should be, if you have a data, there a number of data are there, so it will be structured, unstructured, and semi-structured. So now this particular type of database is mainly used for the purpose of without having the schema. Okay, so this particular type of database is mainly coined in 1998. Okay, so this particular type of database is mainly used in 1998. So it is mainly used to identify the relational database. So it's mainly used to identify the relational database which you are going to have. Okay. Okay, so now, so what this particular database is going to implement? So it doesn't have any SQL interface. Okay, so it does not have any SQL interface, so that to manipulate or does not have SQL interface. So it won't be having any SQL interface. Okay, so to manipulate in query languages. So since you have gone through the database management subject, manipulate and query data. So now, so in this schema, collection script, what you are going to write? So in the collection script, you are going to write the different queries. So scripts is going to retrieve data from text file. So which you are going to have retrieve, it is going to retrieve the data from text file. Okay, so it's going to retrieve the data from text file which you are going to have. So once you have done that one, so it is a this particular NoSQL is going to provide the alternative for data manipulation. So we are going to have the NoSQL. So it is going to provide the alternative for data manipulation. So when you are going to have some alternative for data manipulation, so why we have to go with that one? So data manipulation, why we have to go? What is the necessary of NoSQL coming into existence? So there are two main reasons which you are going to have. So now, so when you are going to make use of the applications, so if we are going to have, why we have to go with a main. So if you go with, so why, what's the reason behind it? So we are telling that it is going to provide the faster alternative for data manipulation. So when it is providing the faster alternative for data manipulation, so it is the faster alternative for data manipulation. So faster alternative for data manipulation we are going to have. So if it is going to have the manipulation, so when it is going to do this particular time, so there are two main reasons which you are going to have. Okay, there are two main reasons which you are going to have. So when you are going to have some application, so the application requires not as application requires a simple data. Okay, so simple data is enough to represent the data using that any application. So using any if you want to run any applications, a simple data is necessary for that one. So reasons, one is to represent the data. So represent the data by any of the application. Okay. So next, when you are going to have the different data, so you are going to have numerous data in the web. So like you are going to have structured data, you are going to have the unstructured data, and you're so if it is the first ticket, so if we take the first ticket, so the unstructured data is increased enormously. Okay, so the unstructured data has been increased enormously. Before the database, okay, so then unstructured data will not relations. Okay, like it won't be having any title or it won't be having be represented as in structured data. So if you take the structured data will be represented in terms of rows and column. Whereas in unstructured data, it won't be represented of rows and column. So since it is unstructured data is increased in the past decades, what will happen? So I have to retrieve the unstructured data uh, effectively. So now there are many stores where you are going to make use of this particular NoSQL. So which are the places which are going to make use of this particular SQL is, so one is different classifications of NoSQL. So basically it is going to be used in document stores. Okay, so it is going to be used in the document stores, so where you are going to retrieve the data. So it is going to retrieve the data from file using some of the scripts. Okay, using some of the scripts is going to have some of the scripts is going to be used. So next you are going to have the graph that is going to be used. So it's going to make use of the graphs, and it is going to be used in key value stores. So key value stores where you are going to have the key ID. So using that particular key ID, so you are going to access the data. So using the key ID, you are going to access the data. So you're going to have the multivariate database. So if you take the classification of NoSQL, so you are going to have the multiple value. So database which are, it will be having the multiple value of database which you are going to have. So now whatever the database you are going to have, so that particular database is represented with respect to the object. Okay, so the database is represented in terms of object. So when you are going to represent the database in terms of object, so in terms of object, so you are going to have, so it is going to be mainly used. Okay, so in this particular type of classification of your NoSQL. Okay, so now when it comes to a tabular store, so as the name indicates tabular, so as the name indicates tabular, so it will be having rows and columns. So if you take the, so it is going to have the schema in terms of this one. So it is going to have the schema. The schema is going to represent it in terms of serial number, particular name you are going to have. So it is going to have 1 2. So this particular table is going to have, so this is how it is going to be represented inside your tabular store. Okay, so when it comes to the, so now so here you can use the tuple. So next is the tuple store. Tuple store has nothing but what, so it is, so it is going to store some of the data. So tuple stores is going to create, and it is going to store the data which will be represented. So these are the some of the classifications of NoSQL. So now when it comes to the NoSQL, so you are going to make use of important prominent implementations which you are going to make use in your so in your data intensive applications, are prominent applications which you are going to support is your, so data intensive application is Apache, CouchDB and MongoDB. So there are some of the databases which will support the which is going to support you the, which will be supporting your data intensive application. So first one is your Apache CouchDB. So they are another, apart from this Apache CouchDB and MangoDB, you are going to have Amazon DB is there. So Amazon database is there. So apart from Amazon DB, so it is going to, you are going to have the Google Book Table. So Google Book Table is one of the implementations which you are going to have. So next is Apache Cassandra is there. So Apache Cassandra is there. So next, after Apache Cassandra, so this is Apache Cassandra is going to help with respect to the distributed databases. So Apache Cassandra is going to help you with respect to the distributed object store. So it's going to help with respect to the distributed object store. So next, the last one which you are going to have is Hadoop DB. Okay, so you're going to have the Hadoop DB, which is going to be used in your, so according to this particular databases which you are going to have. So we are going to have these databases. These databases are being used by these companies respectively. So that means if you are going with Amazon DB, that Amazon DB is going to be used by Amazon only. So your Google Big Table, if you take, so Google Big Table is normally used by your Google itself. Okay. So now, so if you take the Apache account, so if you take the Apache CouchDB and MongoDB, so here this takes what? So this is your document store. Okay, so this is your document store which you are going to have. So in this particular document store, so what it's going to provide, so it's going to provide you the schemaless store. Okay, so it is going to provide you the schemaless store where you can see the primary object. So the primary object is what? So you can see the primary object. So the primary object or documents organized into a collection of key value fields. So whatever the primary objects you are going to have, so the primary objects will be there. So the primary object, what, how it will be organized? The primary object will be organized with respect to key value fields. Okay, the primary object is going to represent with respect to the key value field. So here, what this particular field consists of? So if you take the field, so you can see it here, the field. So if you take any of the database, so if you take that data type, if you are going to have the database or data type into consideration. So here, so the each field which you are going to have, the field which you are going to have, so you can see it here, it will be having the string. Okay, so it will be having the string, it will be having the integer, it will be having the float, so it will be having the date is one of the field, and it may have the some of the array of values which you are going to have. So array of values which you will be having. So now, so whatever the database you are going to have, so the database exposes the RESTful interface. So what do you mean by RESTful? As you have seen in your all your web. So what do you mean by RESTful? RESTful stands for representational state transfer. So representation state transfer. So it is going to make use of the representational state transfer. So representational state transfer, it is going to make use, and it is going to represent the data in JSON format. So next comes the question, what do you mean by the JSON format? So what do you mean by the JSON format? So here, so JSON format is nothing but what? So it is nothing but a JavaScript object notation. So if you take the JSON stands for JavaScript object notation. So it's going to provide you the JavaScript object notation which you're going to have. So it is going to be stored in this particular fashion. Okay, so it is going to expose the RESTful interface, and it is going to represent the data in terms of JavaScript object notation. So now both of them, that is your, so your RESTful interface which you are going to have represented state transfer, so RESTful interface which you are going to have, and the JSON interface you are going to have. So what they are going to do, so it, both of them allow querying and indexing. Okay, so it will allow querying and indexing data. So querying and indexing the data. So by using what method? By using the map reducing programming model. Okay, so it is going to execute, it is going to allow querying and indexing by using the map reducing model. So you can see it here. So it is going to make use of the map reducing model here. So it's going to make use of the map reducing model. So where it exposes the JavaScript as a base language. So in your Apache CouchDB or MongoDB if you take, so both will take the JavaScript itself as a base language. So it's going to take JavaScript as the base language. So you can see it here. It will take the JavaScript as base language. So for what purpose it is going to make use of the base language? So it is going to make use of the JavaScript for data querying and manipulation. So rather than using the SQL, it is going to make use of the JavaScript or JSON format it is going to have. So now when you are going to have using this particular JavaScript, so it is going to, you are going to access the data for large support. It is going to support large files as documents. So when you are going to access this particular database, so this particular database is going to support large files as documents. So it is going to support large files as documents. So now if you take the infrastructure point of view, so both will supports data replication and high availability. So what do you mean by data replication? Support data replication and high availability. So anybody is having the answer for data replication and high availability? So if you take the data replication, so what do you mean by data replication? So now when you are going to access through the cloud, so if you take that cloud, so cloud will be having a number of data centers. Okay, so a number of data centers will be there. So when you are going to have the n number of data centers, so all these data centers will be having the data, right? So whatever the data you are going to have, that will be replicated. So the replicated data will be stored in each and every node. Replicated data is going to be stored in each and every data. So replicated data is there. So replicated data. So then it is going to have whatever the data you're going to have, it should be high availability. Okay, so it should have high availability. So what do you mean by high availability? So high availability is nothing but what? So whatever the data you're going to have, it should be available for you for 24/7. Okay, so 24/7, because I don't know from where at what time if they are going to access the data. So if you're going to have the data, data is going to access all over the world. Okay, so all over the world you are going to access the data. So I don't know when and where they are going to make use of the data. When and where they are going to make use of the data. So for that particular purpose, so it should be highly available. So whatever the data you are going to have, it should be highly available. It should be there. So now your CouchDB, so it has to ensure the ACID property. So all of you have gone through the ACID property, right, in your database. So what do you mean by ACID property? ACID stands for ACID. Okay, so it is nothing but atomicity should be there. Just provide atomicity. So C stands for commit. So I is isolation, and D stands for durability. Okay, so now, so it has to satisfy all the three property. So when it comes to the atomicity, so one transaction, when you are doing the transactional processing, so ACID properties will come whenever you are going to make use of the transactional processing systems. So for example, is your bank. Okay, so bank is example which you can take. So in the bank, what will happen when you want to access, when you want to remove the money? Okay, for example, if you take the removing the money, is one instance what we can take. So now when you are removing the money, so bank will be having some balance, right? So bank will be having some balance. You are going to remove, for example, I am going to have 5,000 in my bank. So I am going to remove 1,000 rupees from the bank. So now the account which is there in the bank, it should access it simultaneously and it has to reduce to 4,000. So now in between the transaction fails, what has to happen? So some of the times you have been encountered this particular problem. So transaction fail is going to happen. So whenever the transaction fail is going to happen, so how much data you are going to make. So that also matters there. Okay, so even if the transaction is failed in between, so whatever the data is previously it has stored, which is 5,000, has to be retrieved. So even the transaction is not successful. So even the transaction is not successful. So it should give the proper value. So if you take the CouchDB. So CouchDB has to support you ACID rule. Okay, ACID rule, all of you know in your from your databases. So it is nothing but your atomicity, commit, isolation, and durability. Okay. So now, so if you take the MongoDB, so MongoDB supports sharding. So what do you mean by sharding? Is the next example. Next thing, so if you take, so it is nothing but what? So it is sharing is nothing but you are distributing the content among the shared among the nodes. So if you take the node, so if you take the cloud environment, so when you are going to have the cloud, so cloud is different from the different node when you are going with a distributed processing. So when you are going with a distributed processing, so each is going to have node 1, node 2, node 3 you are going to have, right? So now, so whatever the content you want to do, so I think some work I have to do or some data. So if you want to work, I have to work with respect to the data. Okay. So the data or whatever the task is been given. So if I want to do it parallelly, so I have to distribute that particular one parallelly to all the among nodes. So this particular process is called as sharding. Okay. This particular process is called as sharding. So sharding is nothing but what? So it's nothing but so the so distributing the content of a collection. So distributing the data. So distributing the data. So it is nothing but what the content of the collection, what they are told is referred as data. So the content of a collection, what they are referred is nothing but the data. So it is going to distribute the data among different nodes. Okay. So it is going to distribute the data among the different nodes which you are going to have. Okay. That's what your how your CouchDB and MongoDB is used in your database, distributed databases. Okay. So next. So next, when it comes to Amazon Dynamo, so the next type of database which you're going to have is Amazon DynamoDB. Okay, so you're going to have the Amazon DynamoDB. So here it is going to have the ring structure. Okay, so this particular Amazon DynamoDB which you're going to have, so that will be in a ring structure. Okay, so that will be in ring structure. So here the distributed key value store supporting the management of information will be done of the several businesses offered by the Amazon. So you are going to have the key value store. So what do you mean by key value store? So key value store is nothing but what? So you're going to have the when you are using your data, when you are going to access the database, for example, access the database. So the data will be accessed with the help of the key ID. So the database will be accessed with the help of the key ID. So when you are accessing the key IDs, so when you are going to have a number of databases, okay, a number of databases which you are going to have. So these databases, what it is you would have, so it should have some store to store the key values. You should have some store to store the key values, and it has to those keys has to be managed. Okay, those key has to be managed. So now, if you want to access the data, means what? All the key value should be stored in the different nodes. So it has to be stored in the different nodes. So in the information, so what in the information it has to be served with the services provided by your Amazon company. Okay, so if you take the Amazon, so if you want to access the resources from your Amazon. So for example, if you take from key ID. So for example, if you're frequently accessing some data are there. So frequent access of some data which you're going to have. So it's going to have the frequent access of some amount of data. So with respect to the key. So with respect to the key, you're going to access the data. So now all these keys which are going to have, it is replicated in, it's going to be it is going to be replicated in all the nodes. So what is the main goal of DynamoDB? So which is the next consideration. If you take the DynamoDB, so it is going to provide you the incrementally scalable and highly available storage system. So it is going to tell that it's highly scalable. Scalable in the sense is what? As and when as a requirement arises, or then when the data is filled, or is filled, so as then when the store filled, we have to what we have to do, you have to enhance the space. Okay, you have to enhance the space of the database. Okay, so you have to enhance the space of the database. Okay, so now, so which you are going to have is, so it's going to be also used as a highly available storage system. That means what? So whenever you want to have, so you should work with respect to 24/7. So it should be highly scalable and it should be working with respect to 24/7. So it should be available 24/7. So now, so when you are going to provide DynamoDB, so for DynamoDB, if you are going to use, so if you are using through the web interface, so if you're doing using through the web interface, what will happen? So we are going to have two different functions. One is get and one is put. So to get the data, you have to make use of the get function. So to insert the data into the database, you have to make use of the put semantic. So now when you are using this one, so this data, what you are going to have, or data what you are going to have, it will be represented in terms of objects. Okay. So the data is represented in terms of objects. These objects with a unique identifier, which is going to be retrieved with a unique key, which you are going to have. So now whenever you are going to make use of the Amazon DynamoDB, so here what will happen here? So it is nothing but your constraints on the properties these systems have. So what are the different constraints that you're going to have? So for example, if you have the asset properties on data have been sacrificed in favor of more reliable and efficient infrastructure. So we're going to have some of the properties of asset properties has to be sacrificed. So some of the asset properties which are going to have, so have been sacrificed. So when you are going to have some properties has to be sacrificed to provide the reliability. So some properties of the asset has to be sacrificed to provide more reliable. So that's the main. By having this one, what it is going to achieve? So by having this particular thing, it's going to eventually constitute a more consistent model. So if you are having the long term, all the users will see the same data. So which means that, so if you have more number of users are using, so the more number of users, if you are going to have, if you are going to have the more number of users, so if you have more, so more number of users which are going to have, all this more number of amount of users, so it's going to be seeing the same data. So it's going to seeing the same data which you're going to have. Okay, so that's what it's going to have with respect to your DynamoDB. This is how the work of your DynamoDB. So this is a typical structure of your DynamoDB which you're going to have. So as I told you that it will be a ring structure. Your DynamoDB will be working with respect to the ring structure. You're going to be work with the ring structure. Okay, so you're going to have pluggable storage device, PDB or MySQL. So request coordinator will be there. Failure and membership detection should be there. So you're going to have the storage peer here. So when you're going to have the storage peer here, so each and every storage is going to have the data. Okay, so each and every it's going to have the replicated data. So you can see the replicated data which are going to have. The replicated data will be here. The replicated data will be here, and all this storage pair will be having the key ID of that particular object. So key ID of the object will be there. So it is represented in the ring structure. So, okay. So it will be, so in a simple manner, what we can tell, it's nothing but the collection of rings. So it's nothing but a collection of rings where it is interconnected with respect to the different node. Okay, so it is going to be interconnected with the different nodes which are going to have. So it is interconnected. Okay, so it is interconnected with different nodes. So it is going to be interconnected with different nodes which you are going to have. Okay, so this is how it is going to be happen in your Amazon Dynamo architecture. So this is will be in some type of data is on the KID. That particular data will be required from that particular data is required from retrieved from that particular database. Okay, that particular data is required from that particular database. So now when you are going to have the failure and membership detection, so if you are going to have membership detection, you are going to have some failure which you should have. Okay, so failure and malfunction detection, which you to search the data. So now to search the data using that particular KID, is not a proper user of this particular resources. So then it is going to tell you that so this particular member is not available. So then you don't have any access to this particular resources. So then if any of the internet connection goes down, so when you are connected, it has to be connected through the internet only. So if the internet goes down, what will happen? So internet goes down. So obviously what will happen? So obviously the data has to be retrieved. So the data retrieval has to be done, which is not possible, and there is a failure. So that will be detected by your this engine, main engine. So that is the repeater programmable storage engine, which you are going to have. It will be done except by the pluggable storage engine, which you are going to have. Okay, so that's what it is going to have. Pluggable storage engine, it's going to work out. So next is Google table. So Google Big Table. So here also it is a distributed storage system. Even if you take the Google Big Table, even the Google table, even if you take the Google Big Table, not that. Certainly, they will do that. But they will come to know that their own guides will be evaluated, and along with the other students who belongs to that slot. Yes. So if you take the Google Big Table, your Google Big Table is a distributed storage system. Okay, so how much it can store? So this particular Google Big Table can store up to petabytes of data. So now, how it will be stored? So it will be stored in the different sources. So it is going to have the data across the world. So whatever the data centers which you are going to have in the Google Big Table, so it's going to be, if you take the cloud, so you're going to have a number of servers. So a number of servers you're going to have. So if you take this one as server 1, this one as server 2, this one as server 3, and this one as server 2. Okay, so thousands of servers will be there like this. Okay, so you're going to have the thousands of servers. So out of these thousands of servers which you're going to have, it can store up to petabytes of data. It can store up to petabytes of data which you're going to have. Okay, so now what it is going to support? So if you take the big table, big table, Google Big Table, so it's going to support you the Google applications exposing different kinds of workload. So what are the different workloads it's going to support? So it's going to support the throughput oriented batch processing jobs. So throughput oriented batch processing up to latency sensitive serving of data to end user. So it will start from throughput. So when you are going to have the throughput, you are going to have the batch processing jobs. So when you So if you take the throughput, so throughput is nothing but amount of work done per unit amount of time, amount of job done, or amount of work done per unit amount of time. So amount of job done per unit amount of time which you are going to have. So when you are going to have this particular big table, so it's going to be used in the different types of workloads. Okay, so one is when it is like throughput oriented. So then when you are going to have the latency oriented, okay, latency serving, latency sensitive applications which you are going to have. So what do you mean by latency sensitive? So the data has to be retrieved faster. So if you talk about the latency sensitive, so latency sensitive is nothing but what? Whenever the request is made. So whenever the request is made to retrieve the data, the time between which the request and the retrieval comes, so that latency should be less. Okay. So when you are going to have the less latency is less, you are going to have to term that. So you are going to retrieve the data very fast. Okay, you are going to retrieve the data in faster manner. So that is what it is going to happen. So one is your throughput based, which you are going to have. Second, you are going to use it in your latency sensitive. Second, you are going to make use in your latency sensitive. So now, if we take the design goals, so what are the different design goals which you are going to have? One is applicability. Okay, so applicability is one of the main design goals which you are going to have, and other is scalability. Scalability is nothing but what? So we are going to have a number of servers. So as and when daily the data will be increasing in the Google. So now if once of at one part of time the database has to get full. That means the file system which it is going to have, it has to get full, right? So when it is full, what I need to do, I have to add one more server. So without making a problem to any other server. Okay. So without the interaction of any one of the person or without sensing, so it has to be done without having any knowledge. The scaling of the storage has to be done effectively. So next is you are going to have the high performance. So this particular system which you're going to have, so it should have the high performance. So high performance should be there, which will be used for that one. So next, once you have high performance, as the last one is with respect to all other database which you're going to have, it will be high availability. High availability means what? So it should be available for 24/7. So whenever, because most of the users across the world will be using 24/7, right? One or the other. So the time zone of the different countries will change. Since the time zone of the different countries changes, so obviously the person who are there in that particular time zone is going to access that particular data. So when they are accessing that particular data, so the data may be kept in any of the server located in any of the country. So they should be highly available at that particular instance of time. So I should not tell that in America if it's morning and in India it is night, I have to access that. So in India it is night, so it is that servers are switched off. I cannot access the data. You cannot tell like that. So even if it is a night here, so if the access is coming from the day, so I have to access it. If so even the access, if the request is coming in the midnight, I have to serve that particular request. So now, whatever the table you are going to have in your Google table, so it will be a multi-dimensional data. So okay, so if you take the Google table, so it you are going to have, so which you are represented with respect to the multi-dimensional data which you are going to have. So it is also be represented by a key. Okay, so it is going to represent by a key indexed by an arbitrary length. So it's going to have the key which will be represented with respect to the arbitrary key length. So here, whatever the client applications we are going to have, the client applications are provided with the simple data access model. So if you take the how that particular client applications are provided, so it's going to provide it with the help of the simple data access model. So simple data access model which you are going to have. So with the help of the simple data access model, we are going to make use of it, and we have to address data at column level, and we have to address data at the column level. So we are going to have the data. So for example, if I take, so if I take this particular data, so it's simple access model. So it is going to be address at data at all column level. So that means what is the heading of this particular thing. So it may be a name, it may be a marks. So like that, it may be there, right? So it may be having the marks 1, marks 2, which you are going to have. So it is going to have the simple data access model, which you are going to have here. Simple data access model. Okay. So these are some of the thing which you should know with respect to Google table. So your Google table which you are going to use is going to be used in your Google only. So this particular cloud or database which you are going to have, this is used for Google application itself. So this will be used for Google platform itself. Okay, which you are going to have. So next is the Google architecture which you are going to have. As I told you that, so one master server there will be there. So master will be there. So you are going to have the worker. Okay, so master and worker, it work with the master and worker. So these are nothing but the worker nodes which you are going to have. So this is one worker node. This is another worker node which you are going to have. So this is worker node one. So you're going to have. So this is also worker node which you are going to have. So all these combinedly, what it is going to have, you can see it here. So this particular servers which you are going to have, this will keep the log files. Okay, this will keep the log files. So all the log files what you are going to keep, it will be in the column form. The log files which you are going to have, it will be in the column form. So when it is in the column form, so from where it is going to access GFS. So you are going to access that one is Google file system. So it's going to have the Google file system, which they are going to make use of. Okay, so all these servers is going to be overall consist overall it is going to constitute in terms of petabytes of data. Overall, it will be having in terms of having petabytes of data, which is going to have. Okay, so that's about your Google Big Table. So next, Apache Cassandra. So we'll discuss in the next class. Okay. So anybody having any doubt, you can ask now. So if you have any doubt, you can ask. So if you have any doubt, Mana, Mulya, have any doubt? So if any doubt, you can ask. Anybody having any doubt with respect to the architecture, or anybody having any doubt with respect to the database support, which will be accessed by your data intensive applications. Okay, so some of the things which you should know. So how it will be utilized using your databases, how it will be retrieved. So if you have any doubt, you can ask. Okay. So in the evening, by evening, I will post you the quiz on this one, on the topic which I have been covered. Okay. So we'll wind up the class for now.